Let's listen to the supplemental problem 3.7. You can find this problem in the ECE302 ebook in the Chapter 3 Supplemental Problems on page 8. Given this NPN transistor, 2 resistors and a battery, can you find the current I and the voltage V if we assume that VBE on is 0.7, VCE SAT is 0.2, and beta F is equal to 100? I'd like you to assume that the transistor Q1 is in the active region, and then check whether that assumption was true or not. Let's first start by drawing a single ground, and then between this node and ground I've got a 10K resistor, and between this node I've got a 2.7K back through a 10 volt back to ground. That's the path back here. My emitter is grounded, and then the base and emitter is here. If you go to page 17 of the chapter 3 notes, there's a voltage source here between the base and the emitter of VBE on, in this case of 0.7 volts, and the current I sub B is entering the base. Here's the collector and the emitter. Between the collector and the emitter, there's a current-controlled current source of beta FIB. I need to show that I sub B is greater than or equal to 0, and the voltage across here is greater than or equal to VCE SAT. Let's solve for the current I sub B. Well, the voltage across this resistor is 0.7, which means the current is going in this direction. 0.7 divided by 10K is the negative of I sub B. That's minus 70 microamps. It's a contradiction because current has to be going in the opposite direction. We don't have to bother to solve for this. Because there's no voltage source here, it would appear that the base current is 0. So I'm going to guess maybe that we're in cutoff and put that model in. Go back to the chapter 3 lecture notes on page 19. The model for cutoff is just simply open circuits between the base and emitter and the collector and emitter. So we take the same schematic we had and just erase the voltage source and the current source. The current coming in here is 0. Of course, the current coming in here is 0. I need to show that the base emitter is less than or equal to VBE on, and the collector emitter voltage is greater than or equal to 0. Let's solve for the base emitter voltage. Well, since there's no current in here, voltage across here is going to be 0 times 10K, and that's going to be the base emitter voltage, which is 0. The collector emitter voltage across here, the rise in voltage is going to be the drops around the loop. V sub CE is equal to minus 0 times 2.7K plus 10. This is less than or equal to VB on, and this is greater than or equal to 0. Our assumption is correct. Now we can solve for I, which is going to be 0, and V is the voltage across the collector emitter, which is 10 volts. And this is supplemental problem 3.7.